Hello everyone, welcome back to my YouTube channel, and in this video we will discuss on how to get the power of a complex number. Okay, so that is by using algebraic method and the straightforward method. Okay, so by using the Moivres theorem. Okay. So um when we get the power of a complex number, okay, let's say our j is equal to the first form is the rectangular, no, so x plus jy. Okay, so let's say um uh, the power is an integer. Now let's say that is n. So if you raise the complex number to some integer n, so that is j raised to n. So similarly, the quantity na x plus jy raised to n. Okay, so when using algebraic method, no, okay, so this um method algebraic na is only applicable when the um complex number is in rectangular form. Okay, so we just have to expand the complex number, no, x plus jy to some power n. Okay, so say for example we have um the power of, let's say, 1 plus j, no, raised to 2. Okay, so in this expression, okay, we should know on how to get the power of a binomial. Now remember, if we have a binomial, now let's say a plus b, okay, raised to 2, that is a squared now plus 2ab plus b squared. Okay, so the expansion of 1 plus j raised to 2 is equal to 1 squared, then plus twice the product of 1 and j, so that is 1 and j, then plus the square of j. Okay, then simplify the expression na. So 1 squared is 1. Of course, 2 times 1 times j is 2j, or j2. Okay, then j squared, guys, now remember j squared is negative 1. Okay, so simplifying the power of 1 plus j, no, okay, to 2 is equal to j2. Okay, so that's how you get the power of a complex number by using algebraic method. Okay, so again, by using algebraic method, so we will use the common algebraic concepts na, like factoring na, binomial theorem, and many more. Okay, now we go to the second method, which is the Moivres theorem na. So in this method, guys, now the process of getting the power of a complex number is much simpler. Okay, because all you have to do is convert first the given complex number into trigonometric form or a polar form, then apply the um principle na behind the Moivres theorem. Okay, so how do we perform the Moivres theorem now? Okay, so first let us illustrate now um on how the Moivres theorem, okay, is done. Okay, so again, in trigonometric form, okay, so our j is equal to r quantity cosine of theta plus, okay, j sine theta. Okay, so we want the power of z. Okay, let's say that is n, integer n. So similarly now, okay, both quantity must be raised to n. Okay, now if we use polar form, so that is r, okay, cis of theta, so that is raised to n. Okay, now we will just focus first now in this form na trigonometric form na. So z raised to n is equal to, okay, applying some property of powers na. If you have products na, let's say AB and then raised to M, okay, you can distribute the exponent to A and B. So that is the same as A raised to M and then B raised to M. Okay, so this expression, r quantity cosine theta plus j sine theta raised to n is the same as r raised to n, okay, quantity, um okay, cosine theta plus j sine theta, okay, raised to n. Okay. Also this one, but I will leave it here now. Okay, so later on, we will write the much simpler um expression for r is theta raised to n. Okay. Now, let's go back to the um um uh, an equation that relates exponential and trigonometric. Now, remember, okay, we have e raised to j theta is equal to cosine theta plus, okay, j, okay, sine of theta. Now, we will try some substitution here, or just replace the variable theta by some other variable, or by introducing a new variable now. So let's say, okay, let us replace, let's say, theta, okay, by n theta. Okay, replace theta by uh n theta. So what will happen, guys? Now, okay, so our e raised to j theta will become u theta, okay, will become n theta. Ayan. Then, on the right side, we have here cosine of n theta, plus j sine theta. Ayan. Sine n theta, I mean. Okay? But remember, guys, now, okay, this one can also be raised to power of n now. Okay, so let's say e raised to j theta equal to cosine theta plus j sine of theta. Okay, if we raise both sides raised to n, so what will happen, guys, now? So on the left side, we have here e raised to j theta raised to n is equal to the quantity cosine theta plus, okay, j sine theta raised to n. Okay, but this expression, by using again power, no power of power property. Okay, so you can multiply the exponents, guys. Now, okay, remember, if we have here let's say a raised to m then raised to n, that is the same as a raised to, just multiply the exponents now, mn. Okay, so that will become e raised to j and theta na equal to, I just copy, okay, sine of theta then raised to n. Okay, now um what is okay, the equality of this expression. Okay, take a look at this sides na. So yung ating e raised to j and theta, sila na. Okay? So e raised to j and theta, e raised to j and theta here. Okay? Then look at the right side, guys, na. Okay? So same lang yung ating left side. Okay? So ibig sabihin kung same to, the right side should be, okay, also equal. Okay? So that's why now, uh what do you call this now? Okay, so therefore, okay, the cosine of theta plus j sine theta raised to n is the same as cosine of n theta, okay, plus j sine of quantity, okay, n theta. Okay. Now going back to this um um expression for z raised to n, okay, we can say that therefore, okay, therefore our z raised to n is equal to r raised to n, and then cosine of quantity n theta plus j sine of quantity n theta. Okay? And similarly now, okay, for this part, guys, now, so ang ginawa mo lang diyan is replace theta by n theta. No? So in polar form, that is r raised to n and then cs of n theta. Okay? So, ganyan kasimple, no, yung paggamit ng De Moivre's theorem. So, just know the equivalent polar or trigonometric form and apply this theorem. Okay? So, later na, we will solve a sample problem na okay, relating the use of De Moivre's theorem. Okay, so our first sample problem here, okay, expand the quantity 4 plus j4 raised to 3. The first method no, should be algebraic, and the second method is by using the Moivre's theorem. Okay, so for the first method na algebraically, okay, so we have here the cube of quantity 4 plus j4. Okay. So in this method na, okay, since the exponent is 3, you can do by separating first the exponent, let's say 4 plus j4, okay, you square, and then next is multiplying, okay, the remaining factor na 4 plus j4. Okay, so you can do this now. The other method is the advantage na of knowing the expansion of binomial, no, okay, with the exponent of 3, no? So remember, if we have a plus b raised to 3, okay, so that is the same as a cubed plus 3 a squared b plus 3a b squared na plus b cubed. Okay, so the expansion of this is if a is 4, okay, if this is your a and this is your b, the j4, so the expansion is 4 cube, okay, plus 3 times the square of 4, so 4 squared, and then plus times b, so that is j4, okay, plus 3 times a, which is 4, then the square of b, which is j4, okay, plus the cube of b, so j4 cube. Okay, then simplify. Okay, ayan, so equal to 4 cube guys is 64. Okay, 3 times 4 squared, 3 times 16 is 48. Okay, 48 times 4 is 192. No, okay, so that is the same as 4 squared is 16 times 4, 64 times 3, okay, is 192. Okay, so plus J192. Okay, the next is 3 times 4 times 4 squared. So same, no? 3 times 64 is 192. But we have here J squared now. So J squared 192. Then plus J cube now. Then 4 cube is 64. Okay? Take note guys now. Take note. Um, the equivalent of J squared is negative 1. Okay? And then j cube, no, okay, you can write that as j squared times j. Okay, again, j squared is negative 1, so j cube is the same as negative j. Okay, so this one can be simplified into 64 plus j192. Okay, j squared is negative 1, so minus 192, and then minus negative j64. Combine like terms, so meron tayong dito ng 64 minus 192, and then plus j 192 minus j 64. Okay, so therefore the expansion of 4 plus j4, okay, raised to 3 is 64 minus 192, negative 128, and 192 minus 64 is positive, no? So j 128. So this is the required expression or answer. Now, okay. Now, how about by using the Moivres theorem now? Okay. Okay, so the first thing to do is to convert or to write the given expression, no? Yung ating 4 plus J4 um into a polar form or rectangular. I mean polar form or trigonometric form. But um you can choose here now. Okay, which one is best for you? So let's say converting 4 plus J4 into okay trigonometric form. Okay, or in form na r um or cosine of theta na plus j sine theta. Okay, so our r here is equal to okay our x and y are 4 and 4, so that is 4 squared now plus 4 squared equal to 16 plus 16, or that is 16 times 2. Okay, so that is equal to 4 the square root of 2. And for the angle, so our theta here is the arctan of y over x, so that is 4 over 4. So since both x and y are positive, the angle theta is in quadrant 1. So theta must be between 0 and 90 degrees now. Okay, so you will get here 45 degrees. So therefore, um the equivalent of 4 plus j4 in trigonometric form is okay 4 square root of 2, then quantity cosine of 13 cosine of 45 degrees plus j sine of 45 degrees. Okay, so applying the Moivres theorem, okay, with n is equal to 3. Okay, so what will happen guys now? Okay, raised to 3, so 4 plus j4 raised to 3. Ayan, and then the um, quantity na 4 square root of 2, okay, cosine of 45 degrees plus j sine of 45 degrees, okay, raised to 3. Okay, so by applying the Moivres theorem, okay, just raise the r in to 3. So 4 square root of 2 raised to 3. And then for the angle, na just multiply the angle by the exponent 3. Na. So that is cosine of 3 times 45 degrees, okay, plus j sine of 3 times okay 45 degrees. Okay. 4 square root of 2 is 4 cube guys is 64, and then square root of 2 raised to 3 is 2 square root of 2. So 64 times 2 square root of 2 is 128 square root of 2. Okay. Then 3 times 45 degrees is 135 degrees now. Cosine 135 degrees. Okay, plus j sine 135 degrees. Now, what is cosine of 135 degrees? Okay, that is equal to negative square root of 2 over 2. Then plus sine of 135 guys is positive square root of 2 over 2. Distribute 128 square root of 2 to this expression. So 128 square root of 2 times square root of 2 guys is um 2 over 2, so 1. So just copy 128. And we have your negative sign, so you will have negative 128 here, then plus this is plus now. So plus j 128. Okay? Ayan. So as you can see, the answers now in both methods are just the same. Okay? Okay, our second problem is to express cosine 3 theta in terms of cosine theta only. Now, so in this method, syempre, we will use complex numbers. To be specific, so um by using the Moivres theorem. Okay, remember, okay, if we raise um cosine theta now plus j sine theta to some integer n, okay, it will give us cosine of n theta quantity, okay, plus j sine of quantity n theta. Now what if, okay, okay, if our n is 3, okay, since the required expression, the problem is the expression for cosine 3 theta. So this suggests that we will raise na the expression cosine theta plus j sine theta, okay, to this number which is 3. So we will set n is equal to 3. Okay. So therefore, the cosine of theta na plus j sine theta raised to 3, okay, is the same as, okay, cosine of 3 theta plus j sine of 3 theta. Okay. Now, since we have here an equation, the trick here is to equate the real parts of the left side to the real part of the right side. Since our required here is cosine 3 theta. And cosine 3 theta here is the real part of the right side. Okay. So, obviously, the expression for cosine 3 theta is also the real part now on the expansion of the left side. Okay. Now, on the left side, we cannot use the Moivres theorem anymore since if we will just repeat on the right side. Okay, so you have no choice but to expand the left side now by using an algebraic method now. Okay, so remember the method in getting the cube of a binomial now. Okay, um now the expansion cosine cosine of theta plus j sine theta, okay, to 3 is equal to, okay, so first the cube of the cosine, so that is cosine theta cube, okay, plus 3 times the square of the cosine theta multiplied by j sine theta, okay, plus, okay, 3 times cosine theta, then times the square of sine theta, j sine theta, and then the cube of j sine theta. Okay. Simplify. Okay, this is cosine cube theta plus 3 cos squared. Okay. Then j sine theta. So obviously this is j3 cosine squared theta sine of theta. Okay. Here now we have here j sine theta squared. So right first j squared. Okay, 3 cos theta. Okay. Then sine squared theta. Okay, plus j sine cube theta. J cube sine cube theta. Okay? Yan. Simplify further. So cosine cube theta plus j 3 cosine squared theta sine theta. Okay? Then j squared, guys, remember j squared is negative 1. So minus, okay, 3 cosine theta and then sine squared theta. Okay? What is j cube, guys? That is negative j. Okay, sine cube theta. Then combine same parts. Okay, real to real and then imaginary to imaginary. No? So the real parts here are cosine cube and then negative 3 cos theta sine squared theta na. Okay, so cosine cube theta minus 3 cos theta and then sine squared theta. Okay, whereas the imaginary parts here are the okay, 3 cosine squared sine theta and then sine cube theta na. Okay, so that is plus quantity 3 cos squared theta sine of theta minus sine cube theta. Okay, now what is this na? Okay, the cube of cosine plus j sine is the same as, okay, this na cosine 3 theta plus j sine 3 theta na. So that means na, okay, this expression, okay, is the same as, okay, cosine 3 theta, okay, plus um j sine of 3 theta. Okay, so um the next step na is to equate same parts na. Okay, to equate, okay, cosine 3 theta, okay, to this part, cosine cube theta minus 3 cos theta sine squared theta na. So therefore, the equivalent expression for cosine 3 theta is equal to cosine cube theta minus 3 cos theta, then sine squared theta. Okay? But the required answer, I mean, is to express cosine 3 theta na in terms ng cosine theta only. Okay? So from Pythagorean theorem, okay, remember, we have cosine squared theta plus sine squared theta is equal to 1. So that means the equivalent expression for sine squared theta is 1 minus cosine squared theta. No? So rewriting this part, okay, the expression will become cosine cube theta minus 3 cos theta by quantity 1 minus cosine squared theta. Distribute 3 cos theta, negative that na. Okay, minus 3 cos theta. Okay, negative, negative. Okay, it will become positive now. Cos theta, then cosine cube theta. Okay, it will become cosine cube theta. Okay, cosine cube theta plus cosine cube theta plus 3 cosine cube theta. Okay, combine like terms, so cosine cube plus 3 cosine cube is 4. So 4 cosine cube theta minus 3 cos theta. So as you can see, cosine 3 theta now is just in terms of cosine theta only. So this is our final answer na. Okay? This is the expression for cosine 3 theta in terms ng cosine theta only. Okay? So that's it guys now for our today's video na. And if you have question, just comment down below and see you next time.